development. So we have mentioned previously that the software development process, now we have multiple say users are there, or multiple stakeholders are there. There are multiple developers. There are number of members in the team. Different members have different kinds of traits, characteristics, and every member may be shared with other projects also. So there is a lot of chaos in software development. So we have seen certain examples. You have requirements which are not uniform. Okay? Requirements may be from different stakeholders. Different requirements are there. So we have to negotiate and bring them to the list of agreed upon requirements. So in that sense, we are this prescriptive process models will try to bring the order in this kind of a chaos. Okay? So whatever the chaos is there in software development process, it tries to bring order. Okay? Second is it is supposed to bring, or it bring a certain amount of useful structure. Okay? So when process models are there, like we have seen last time, process flow models. Okay? Process flow has been seen. So we can see there is a structure, either it's parallel or evolutionary, or it can be iterative or linear. Okay? So it has some kind of a structure when you build a software. Okay? So software development process will have a structure. We also mentioned that it also provides you something called as a roadmap. So planning. So when we talk about planning, we mentioned that you require some kind of a map. So when you go from one place to another place, you require a map. Similarly, when you build a software, you need a map from requirements to the developed product or the deliverable product. Okay. So what we are having here is, now again we are having a roadmap. So it provides a reasonably effective roadmap for building the software effectively. Yeah. And then, though we are having these things, we say there is something called as software engineering work and the product that it produces remain on edge of chaos, because you have to balance these two things. We also mentioned that the development of product requires some kind of flexibility, some kind of autonomy given to the developers also. Yeah. So edge of chaos means sometimes you focus on following the structure as it is, and sometimes you require some kind of freedom. Okay? So there is a you are on the edge of following the order or following the chaos, because when you say autonomy is there, autonomy means every person will start working with his own speed, with his own intellectual things, with his own set of understandings. Okay? So that's a chaos. Okay? Another side is order because we are having a process model. We are supposed to do as per some kind of a standards, some kind of a documentation which is already existing. We're supposed to follow those things. Okay. So now this is where we need to balance these things. Okay. So this process models will provide you that software engineering is on the edge of chaos in this case. Okay. So work and product that it produces remain on the edge of chaos. Okay. So prescribes, why it's called as, we also discussed why it is called as prescriptive, because it prescribes a set of process elements. Set of process elements are prescribed what to do. Okay. So whenever a project comes up, you want to develop a software, it says, okay, now you follow this framework activities, you follow this software engineering actions and tasks. Okay. These are prescribed. So prescribed things are there. And then in the umbrella activities, you say, okay, for when you are doing this kind of activity, you say that we are going to provide this kind of a product. Okay. So requirements will have SRS document. Okay. So work products are there. Okay. So it prescribes certain work products, prescribes some quality assurance activities, quality assurance measures. It prescribes change control mechanisms for each project. Okay, that's what it provides for every project. Okay, that's why we call it as a prescription. We say we are having some kind of a prescription provided by these kind of models. Okay, so under these models, if you see what we are trying to discuss are, there are various models available. We are trying to discuss some models out of this. Okay. So waterfall model, incremental process is called as RAD, rapid application development model, evolutionary process model, unified process model, and concurrent process model. So these are various process models which fall under this prescriptive category. Okay. So this if you see, we have already seen some process models from this. So again, prescription is there, prescribes the process workflow, which already have seen. So we have seen 4 process flows, iterative. So iterative is kind of an incremental process model. Okay. Evaluation process model we have seen. We subsequently will see these two are different, unified and concurrent models, and we have waterfall model, which is nothing but a linear process flow is there. Okay. So this kind of things are present in under this prescriptive process models. So we'll see this one by one now. So waterfall model. So as the name suggests, if you see, it's a waterfall. So what happens in waterfall is, can somebody tell? Everybody has seen waterfall. Can somebody tell what is a waterfall? Yes.
Water
I'm
flows
waiting for
from
your
high
answer.
level. Water flows from high level
To low
to low
level.
level in a
Okay.
stepwise pattern.
Yes. Will it go back? Once it's falling down from half, will it go back to the top again and start falling down?
No, sir.
No, there is nothing like that, correct? So water flow means once water starts flowing from top to bottom, it just goes down. There is no coming back. You are not stopping somewhere and coming back as such. Okay? So that's the case of waterfall models. Now, where it's useful, we see that there are certain situations in which cases waterfall model is very useful. Okay? Now, first is work flows from communication through deployment in a reasonably linear manner. Okay? So this is a case that you know that this small project is there. So in small project, you just talk with the customer, you take all the requirements. So communication phase is over. So because you know that I have all the requirements. So once all requirements are there, then for the next stage, okay, planning phase, design phase, then implementation phase, and the maintenance phase. So you are going one by one. If you see like this, if you go by this fashion, then we are not coming back. So because this is a small project, you don't require to do say again communicate with the user as such or your stakeholders for confirming something from them. Not required. So you just continue doing those things. So that's the first case. Second is well-defined adaptations or enhancements to an existing system must be made. So you know that we are having an existing system, so which is well studied, which is well known to the entire team because they may be the ones who have developed this system. Now, because they know everything in and out of that system, there is some kind of enhancement to be done, some change, some modifications to be done. So, and these enhancements or adaptations are well defined. So there is nothing like you have to keep on doing the iterations with the stakeholders, whether it's correct or not. So there is no need as such. You know there is a well-defined adaptations. Or it may be the case that you just have to add some kind of a custom or reusable component which is already existing. You just add that, integrate, your system will be ready. So in those cases again, you can use the waterfall model. Next is new development efforts with well-defined and reasonably stable requirements. Remember here, we are saying new development efforts. So obviously, whenever you are having new developments, we'll have a chaos, okay? And we require a specific process model. And for generally for new developments, whenever they are there, we say requirements may not be known in that case. All requirements may not be known. There may be some kind of ambiguity. There may be some kind of a misunderstanding between the customer and the developer team. However, this is a specific case wherein we are saying we have well-defined and reasonably stable requirements. So if you see, these situations are such that there is no change happening in the requirements. Once the requirements are given, we say these are requirements which are fixed. This will not change. So the requirements will not change. That means yes, now I can just have the same I can freeze the requirements and go for the subsequent stages. So if you see the diagram just below, it's a sequential flow. It's a sequential flow. It's a linear flow is there. Okay? So it's a linear process model in that sense. So we have this framework activities are there. So communication, that is project initiation, requirement gathering. Once it is done, we're not going back to the communication phase. We'll finish this. We'll have requirements which will be stable requirements, which will be agreed upon. Then we'll also say that we are not going to add anything on these requirements as of now. Let this finish. So these freeze requirements will be planned, will be estimated, scheduling will be performed, and tracking of this obviously as a your umbrella activity will also be performed. And the new model analyze the plan as well as your and design the requirements. Go for coding, testing, and delivery. So it's a linear flow. It's a water flow. It's going from one phase to next phase, next phase to next phase, next phase to next phase. till deployment. There is no coming back in this case. That's a waterfall model. So little history about this. So if you see this waterfall model, it's proposed by this Winston Royce in 1970. Okay, so almost 50 years before this waterfall model was proposed. Okay? And it is still being used. It's not that it's not being used. It's still being used for, say, small projects or wherever we have mentioned the situations wherever you are having well-defined requirements, where requirements are stable and they will not change. This waterfall model is still in use. Okay? So what happens here, if you see, this model has a characteristics. It's also called as classic life cycle because of its nature and because it has been used for a long period of time too. So this model is quite systematic because what is expected here is every phase you take utmost care that you finish all those things. Okay? So subsequently we'll see that we should spend sufficient amount of time on requirement gathering. We should not just directly jump on the coding or designing or say modeling or planning things. Spend sufficient amount of time in requirement gathering. It's very important phase. Many books, if you refer, they will say that the more time you spend on requirement gathering, okay, clarifying from the customer and making it sure that all requirements are there, okay, you require less amount of time for subsequent things, as well as it reduces the cost dramatically. So overhead, if you see, if there is no 0% of time spent on the requirements, they say that you may have to spend hundreds of time more cost. Okay, so cost over costing may happen. It will be in the multiples of hundreds. Okay? So that will be the case. Okay. Second case is if you say spend some 5% to 10% of time, you will see that the this over costing subsequently that may occur will be reduced. Okay, it will just be say 50 to 60%, and if you spend around 20% of time, 10 to 20% of time, will be reduced to same say 10 to 20%. So, but it is not zero. So even if you spend say 50% of time, it doesn't say that your over costing will be zero. You will overrun. There will be cost overruns will be there, but there will be less. So spend sufficient amount of time, say for your considering the entire project time, spend at least 10% of the time for your requirement gathering. So if you see this waterfall model, it makes it sure that you have all the requirements beforehand, before you go for the planning phase, before you go for the next framework activity. That's why it's called systematic. Obviously, it's a sequential approach for software development, and how it begins that we already seen. Okay, it begins with customer specification of requirements. Okay, so there are two specifications we'll subsequently see. One is customer specification of requirements, and second is developer specification of requirements. Okay, there are two. Okay? So when this customer specification is there, that's where you're getting from the customer that what he exactly wants. And once that is understood, now it's your internal matter that you tell now these are the requirements from the customer. This is how we see as a developers. So developers will have a different document because there will be more technical details in specification document. Okay? So that's from the point of view of a developer. That's called as we say SRS. Okay. So we'll have two SRS. One is for customer SRS, and second is developer SRS. Okay. Software requirement specification documents. Okay. So begins with customer specification of requirements, then goes to the planning phase, then modeling, construction, and deployment, culminating in the ongoing support of the completed software. Okay. So what happens is you deploy the product and then you start supporting the product. So in these cases, again, if you want to add some kind of a change, what we expect is, okay, if change is there, it's well-known change. Okay? It's enhancement. Its enhancement is there, which to be performed. So in that case, again, it's whatever additions are being performed, enhancement being performed, we will again go through the waterfall kind of a model. We don't consider them as iterations. We don't consider them as evolutionary because we have followed a simple process. We haven't planned already that we are going to build some as a core functionalities and some as enhancements. If that is the case, we have different models for that. But right now, what model we are using or we are discussing is, in which case all the requirements are discussed, and then you go for the subsequent phases of the framework activities. Okay. A variation of this waterfall model is called as V model. So presentation has a different way. So one we are just mentioned as a linear fashion. Okay. What happens in this V model if you see? So on the left hand side the activities are coming down. So they can say the earlier engineering actions, and then on right hand side if you see the up arrow is there, it is a verification and validation actions. So that's a V model. It forms a V. Okay. Why? Because there is a there is some kind of a interaction. Okay. Relationships are there between the verification and validation actions to the engineering actions, okay, which we do in the framework activities. Okay. So in the framework activities are those till we code as okay. So communication, or where we calculate the requirements. So modeling, architectural design, component design, and code generation. These are called as engineering actions. Okay. So apart from your requirement gathering, from starting from requirement modeling to the code generation, are considered as your engineering actions. And right hand side is verification and validation of these actions. Okay. So that's where we say yes. Now we are having a V model in that case. Okay. Now what happens in this case is the software team, if you see, they will start moving down in the left hand side. Okay? Left hand side of a V, we are moving down one step at a time. So from requirement to code, that's understood. Okay? And then once the code is ready, once our code is ready, the team starts moving up, okay? Like unit testing, integration testing, system testing, and acceptance testings. That's when we say, okay, now my everything, all the things are checked. Okay. So if you see unit testing, what we do in that case is code is available with us. Okay. Code is ready. Code is ready, and in that case we are testing every function. Okay? Every function that we have defined, we have written, is tested against whatever test cases you have generated. Okay? Once that is done, you go for integration case, where you test the components as well as the architecture. So if you see in unit testing, we are testing functions as well as when they are merged together, where then clubbed together, when they're integrated, we form a component. We do test individual components too. Okay? So we can say standalone things will be checked in unit testing. When you go for integration, along with the components, you also test for architectural designs. Okay? Whether my components are fitting into architecture or not. So that's where integration is being performed. Okay? So integration testing will be done for that case. Then do system testing. So along with architecture, you are checking that all my requirements are tested. Okay? Whether they are, whether this software is working for all the requirements that are defined by the customer. Okay? So for all those models, all those modeled requirements, system testing will be performed. And once that is done, now what I'm doing is acceptance testing. That means it's a complete black box. It is as if a user is using that system. So there is no developer. You are having a user. So it means you may say that okay, I'll give it to customer, and customer may check for its requirements. Okay? So whatever requirements he has given, he will provide the inputs and check for the outputs. If it is satisfied, okay, then we will say okay, now this product is working as per our requirements. We can accept this software in that case. That's verification and validation actions against your engineering actions. That's the V model. Okay. So this, if you see, it's the oldest paradigm because it's 1950s. 1950 it was defined, or it was developed. Okay. However, it's questioned for efficacy. Okay? Because there will be certain cases. Why efficacy? There will be multiple reasons for that too. Because today, if you see, we want to build softwares at a very fast rate. Okay? So, like even if you say in your laboratories, what you do is you are given a assignment statement, and it's expected that you finish that assignment in that 2 hours only. So that means in those 2 hours, you have to understand the requirements, you have to model the requirements, you have to perform this designing also, and you have to create test cases too. You have to write the code, you have to test the product, and check for all quality assurance things. Okay. So if you say in this 2 hours only, you are developing one function of one function, you can say, of a software which may be part of a bigger software. Okay. So right now we want to build at a faster rate. Okay. And definitely nowadays, if you see softwares, they're coming with lot of changes. Okay. What we say is never-ending changes will be seen in the software, and in those cases, then waterfall model will not suffice or will not provide as such. Okay, provide for. Okay, maybe inappropriate. You can say it's inappropriate in the cases where there are a lot of changes coming up. Okay. So changes may be coming up for say features or functions or some kind of information contents. Like you may say, I would like to have this to be used on this kind of a system. Okay? Like we say, we are using Teams. Okay, many of you are using on on mobile phones. Some of you might be using on Linux systems. So if you see this Teams, it's still being built. It's not complete. Okay? There are many functions which are not available on your mobile app. There are many functions which are not available on say Linux based systems. Okay? If you want to use this on Linux based system, so there are certain things which are continuously being changed. Okay? So now you say earlier this was meant only for conducting meetings, okay? Taking some notes. Now because it is supposed to be used in education systems, so what they have done is they have added a parameter called as attendance. Okay, so that we can take attendance. Okay, let me take attendance for the day because you will forget, it becomes a problem. Okay, attendance. So now what is happening, if you see, even if I download once, sometimes it may happen that attendance comes out as blank. So I will take multiple times. So what I do is I take 2 or 3 times attendance in this last say between 15 minutes. So 9:30 to 9:45, I take 2-3 times so that in at least in one I will have complete attendance available. Okay? So it may happen like that. So these are changes which are being performed. So in such scenarios, waterfall model is not useful in that case. Okay. So that's where we are saying that yes, it's good. It was there. However, it's question for efficacy. Okay? And other things are we may have some kind of problems too. We may have to encounter some problems like relay projects rarely follow the sequential flow. So real projects, there you may require you may require iterations. You may require to come back to customers. You may require from planning phase to the communication phase. You may have to come back from model again to the planning phase or model to requirement phase. So it may have to go for from current phase or current activity to previous activities in the process flow. So in that case, real projects nowadays require this kind of iterations. So sequential flow is not being followed. Second, it's often difficult for the customer to state all requirements explicitly. So if you remember last time we discussed, the customer is unaware about the requirements or he's not able to clearly define the requirements because he has an idea that is, yes, I want to build something, but he has no clear understanding what all functions he want to have in the what all functions he want or how he wants these functions to be seen in the software. He only knows that I have some kind of a problem for which I require a software solution, but requirements are unclear. So that's the problem. Okay? And in such scenarios, again, we cannot have waterfall model because waterfall model requires you to fix all the requirements in the communication phase itself, which is not possible in such scenario. And third is a working version of the programs will not be available until late in the project time span. What we say is we are going step by step. So if your project takes say 1 year, if your project is big project, it takes 1 year for completion, and your coding or implementation will be finished say in the 10th month. So till 10th month, you will not have any working version of a software available because you are building entire software as a single unit. Okay? A single unit is as a single product. Okay? And there are all interfaces with each other, and you are saying that this integration will be finished only in the 10th month. That means I will not be able to see even the core requirements. Your core functionalities will not be visible in that case. That's the problem because customer will always be anxious to see what is happening to my software, how much the development has been done by this team. Because even if they are giving you something, they would like to have some kind of reports or some kind of feedbacks. What is being done? Tell us these functions are done, because you know that we say based on the work completed, they provide you the money. Okay, so funding or the capital will be given as and when you say, okay, this is done, this is done, this is done. So as milestones are achieved, accordingly the customer keeps on paying. Okay? So there is a phased wise payment being performed by customers. So in that case, if you are not providing them the documents or you are not providing them the deliverables, how will the customer pay for it? Where is the stakeholder? How will he pay for it? Because he needs to have something with him to give you the money. So that's why this kind of a scenario is in such cases, this waterfall model will not be useful or it will be inappropriate. Okay, and linear nature of the classic cycle leads to blocking states. Okay, what happens is we fix the requirements and then we go for planning. We block the planning state and then we go for the next. So there is a no coming back as such. Okay? So that leads to this kind of a what you say is blocks or blocking states. Okay? That's our waterfall model. That's we say waterfall model may be good for small projects, but may not be good for the cases where requirements are changing. The customer doesn't know all the requirements when he's giving you the product, and the problem is deliverable. This entire project will not be visible, and a customer will not be able to access it until and unless the entire all functions are implemented. Okay? So in such cases, this waterfall model is not useful. Okay? Second is incremental process model. So again, we are having some situations. Now this is more like what we would like to have. So situations are initial software requirements are well defined but cannot be linearly developed. There are such situations like this. Okay, yes, we have software requirements available. They are well defined. However, we cannot build all the or we cannot model all the requirements simultaneously together and then go for the next step, because we say, okay, we need to test if this functions, then the subsequent part can be added. So that's what we are saying. There is dependency is there. If something, some function is not working and it is the one on which the subsequent functions are dependent on, there is no point on building the subsequent functions without building this function, okay? Dependent function. So these are some certain things. Okay, so first we go for this kind of a requirements, or we can say the core functionalities or the dependent requirements or dependent functions. So if the dependency is not satisfied, subsequent things cannot be done. If dependency is developed, okay, then we can go for the subsequent functions. Okay, because these are dependent on this functionality. Okay? That's where we say we are having incremental process models. Okay. So this is also called as rapid application development models, where you say, okay, first is this is core functionality, it is done, go for the next function, next function, next functions. Likewise, you can add. So deliver core functionalities quickly. That's why it's a rapid application development. Rapidly you develop core functionalities and then refine and keep on expanding. That's what we have seen in the incremental process model flow also. Okay, where we mentioned that we are having increments being provided. Okay. In evaluation also we'll do similar kind of things. However, here we are refining and expanding, refining and expanding, refining and expanding is being done rapidly. So what happens here is this model delivers a series of releases. Okay? They're called as increments. Increments will keep on coming. Increments will keep on coming. Okay? So what is the characteristic that provide progressively more functionality for the customer as each increment is delivered. Okay? So we have more and more functionalities added. Okay? At the same time, refining the existing functionalities or requirements also will be performed. Okay? So it combines elements of linear and parallel process flows together. Some things will be done in parallel because refining of earlier things means you are doing those things in parallel. Okay? Linearly in the cases for the current activities, you are adding those things and you are building those things and adding into the product. Okay? So some things will be done in parallel, something that will be in a linear fashion. Okay? That's the incremental process model. So example here is, if you see, developing a word processing software. So if you are asked to develop a word processing software, okay, so it can be anything. You can take example of your Word also, but however the word that you are using, you are directly using say Word on Microsoft Word 10 or you are using Office 365. So in that case, you have seen a version of software which is fully functional or which is having a lot of functionalities, many of which you may not be using only. Okay? However, if you see the earlier softwares or earlier word processing tools that are available, or even if you want to develop yourself, what you will do is first you may just go for file management activities. Okay? Like I should be able to open the file and then write something and save the file. So that is first thing that we will do, because if the file is not openable, if you cannot create a file, how will you do? So file management activities may be performed first in that case. Then you may provide subsequently editing facility. Okay, first we just read, open, close, and read. Okay? Subsequently, you may say, okay, now I will add subsequent functionality as editing. you can write something in the file and you can save that. Okay? And then you can subsequently have, now I can produce this document as, save as a doc file or docx file or PDF file or some various different number of options I can provide. So I'm converting the same document into multiple number of types of documents in that case. Okay? So likewise, you say, see now the Microsoft Word as such. Earlier it was not providing you say PDF, save as PDF as such. Now it is giving you the facility of PDF too. Earlier it was just providing the facility of doc or .rtf, rich text format was there. So now you are seeing more and more functionalities are being added. Okay? So basically earlier you provide the core functionalities and subsequently you add some sophisticated things. Okay? So even say you initially you provide the the file management activities and editing activities. Subsequently you may provide for say adding diagrams or say providing shapes, adding diagrams. Now that's done, then in the next increment you can provide for adding equations. Okay? So adding some kind of equations, you can add those things. Further you may go for the next increment wherein you will keep on refining these things. So you may say that earlier you added the shapes like say text boxes or the rectangles and squares and other things and arrows. Now you can add 2D arrows, 3D arrows, or you can add different kinds of more, or you can say more shapes you can add. So you are refining the earlier functionalities. Simultaneously, you say you are adding the equations, okay? Mathematical equations. You can write more mathematical equations. Then you may say, okay, now after doing these things, when you're incrementing this, when you're refining these things, I'll add more like spell and grammar check. Okay, so you can provide for spelling and grammar checking as the next increment. Okay, so likewise you can keep on increasing the functionalities in the incremental process models. Okay, so what is happening here is, though requirements were initially defined, some requirements are initially defined, some are not defined, but as you go ahead, you are building one after other. Okay? Building one after other, something in parallel, something is linear, and you are having increments. Every time you are giving more and more functionality to the customer within every increment as such. Okay, that's what we talk. We say that we are having something called as a incremental process model. Now, if you see in this model, what diagrammatically we represent is in this fashion. So we have process calendar time, and we have software functionality and features which are available. Now you see increment 1, we are having something. If you see, you may say it's a linear. Though it may not be a linear every time, we may have, when you see increments are there, we are doing some activities in parallel too. We are doing some activities in linear fashion also. So you may have some fixed requirements for which you follow the linear fashion. When this increment is being delivered, okay, like you see in this phase, this is a parallel. Okay, so when you are in construction phase or testing phase, construction testing phase of the first increment, you are starting to work on the communication that first product is ready or first core functionalities are ready. Now we can go for the enhancements. Now you tell us the enhancements. So that's where you will see that some activities will go in sequence. Okay, these are going in sequence. Okay? First increment. Okay, and this is where you see these are being done in parallel. Okay, so when deployment is being done, you can go for planning for the second increment. Okay? So likewise, we can have multiple things. So here also we are showing that you can go like this. Okay, so we are having some certain things done in linear, certain things done in parallel. Okay? So this is in the product calendar time where we keep on adding functionalities and features. So this now y-axis, if you see, it is giving you the increased functionalities with every increment. We are having more and more functionalities added. So that's how this functions. Okay? This is how your incremental model functions. So first increment is often considered as a core product. Many times it may happen if requirements are not clear, like we have mentioned earlier also. You may create a first increment which may not be used subsequently. You may just discard it just to understand what all requirements the customer has. Okay? That may be the case, or this may become a part of your subsequent or final product also. So that may be the case. That depends on how you choose. Okay? Like we have mentioned in the last class that we have taken a pattern. Okay, So in the pattern we mentioned that requirements unclear. So there we gave the solution as use a prototype model, a kind of a incremental model. So if that is the case, you build a prototype, and based on prototype, you will see that customer now understands more and more requirements. Now you may choose to have this prototype as a part of your final product, or you may just discard it and start building with the new requirements or the stable set of requirements that you have got from the user and work based on that in an incremental fashion. That may be performed. Refinement and supplementary functionalities in subsequent deliveries will be performed after the core product is ready. That's how this incremental process model will function. Next in this category is evolutionary process model.